Hello students, we are happy to have you join us on this exciting journey into the world of computers with binary brains, the language of computers. Grade 7 Lesson 5. In this lesson, we are going to learn more about Python programming, conditional statements, indentation in Python, loops in Python, data structures, functions. Let us begin learning more about Python programming. We have learned the basics of Python programming in grade 6. Now we will learn how to make our programs more innovative. In this lesson, we will learn new features of programming language, conditional statements and loops, data structures in Python like list, tuple, dictionary and sets and functions. Steps for using Google Colab. Open your browser and go to google.research.google.com. Log in using your Google account. Click New Notebook to start writing Python code. Click on the bar that says Start Coding or Generate with AI and start writing the code. Press the play button next to your code cell to run your program. Conditional statements. Consider the example of a traffic signal. The drivers make decisions based on the colors. Red means stop, yellow means get ready, and green means go. In Python, conditional statements if, else, elif work in a similar way to guide the computer's action based on true or false conditions. Let's learn how to give the computer instructions to make smart decisions. For example, consider the conditional statement, if your age is less than 18, then you are not eligible to vote. In Python, this would look like this. Let us run this code. Now let's enter age as 12. Here, if tells the computer to check if the age is less than 18. If the condition is true, that is, if the age is less than 18, it follows the first instruction. It prints you are not eligible to vote. As 12 is lesser than 18, we get the output as you are not eligible to vote. If the condition is false, that is, if the age is greater than or equal to 18, it follows the second instruction with else. That is, it prints you are eligible to vote. We shall run the code again and enter the age as 25. As 25 is greater than 18, we will get the output as you are eligible to vote. Types of conditional statements. In Python, there are three types of conditional statements that are if else, and if elif else statement that allows you to make decision in our programs. If statement. An if statement in Python is like giving the computer a condition to check, and if the condition is true, it does something. The syntax of the if statement is, for example, in this Python code, the program checks whether the if condition, that is age is less than 18, is true and performs the next action based on it. Let us run the code and enter the age as 15. 15 is less than 18 if condition is true. So we can see the output as you are not eligible to vote. Now we shall run the code again and enter the age as 30. As 30 is not less than 18, the if condition is false. As we have not given any instructions in the code for the action to be taken whether the condition is false, therefore the code will not give any output. If-else statement. An if-else statement in Python is like having a plan for two different situations. The syntax of if-else statement is, in this example, we have assigned the value 20 to the age variable. Here, the computer checks if the age is greater than or equal to 18. If the condition is true, it follows the first instruction and prints, you can get a driving license. As we have assigned the value 20 to age, the if condition becomes true. And so we get the output as you can get a driving license. When we enter the age as 17, then if condition is false. It follows the second instruction and prints, you cannot get a driving license. It is like having a backup plan if the first condition is not true. If elif else. An if elif else statement in Python is like having multiple choice to pick from. The syntax of the if elif else statement is, in this example, the user is asked to enter two numbers. If the numbers are equal, the output is both the numbers are equal. If A is greater than B, the output is first number is greater. And if B is greater than A, the output is second number is greater. Let us run the code and enter the first number as 3 and second number as 3. The computer checks if the numbers are equal. The if condition is true, it follows the first instruction and prints both the numbers are equal. Now we shall run the code again and enter two different numbers this time. We will enter the first number as 5 and second number as 3. The computer will first check if A is equal to B. As 5 is not equal to 3, the if condition is false. The computer will move to the second condition. The computer will now check if the first number 5 is greater than the second number 3. As the condition is true, it will follow the second instruction and print first number is greater. Again, now we will run the code and enter the first number as 7 and the second number as 20. The computer will check the first condition. As both numbers are not equal, it will move on to check the second condition. The second condition of the first number being greater than the second number is also false. The computer will now move on to the third condition. As the second number 20 is greater than the first number 7, it will follow the third instruction and print second number is greater. When we use multiple conditional statements in a code, it is called nested conditional statements. Indentation in Python. Students, consider that you're building a structure like a bridge, a castle, or a house using Lego blocks. Now, you would not stick them randomly, right? You would place them in a correct position as required to ensure that the structure is strong and stable. Indentation in Python is a similar practice of stacking the blocks correctly. It is how you show Python which code belongs together, like which blocks are a part of which level in your tower. Let's look at a simple example. See how the print lines are indented with spaces? That is how Python knows those lines only when the given if condition is true. This makes the indentation extremely important in Python because without it, Python would get confused and not know what you meant. It also helps keep our code organized. Now let's look at loops in Python. Looping statements in Python are like doing something over and over again until you finish a specific task. For example, read one page of the book daily until the book finishes. Suppose you want to print numbers from 1 to 5 using print function. It can be easily done like this. In the same way, if you want to print numbers from 1 to 1000, it will take a lot of time, won't it? You will have to write print function from 1, 2, 3 and so on until you reach the number 1000. This is exactly where the concept of loops will help. Let us know about types of loops. For loop. A for loop, also known as counting loop, repeats a task over and over either for a set of number of times or through a list of items. We use a variable to create a for loop, which is called loop variable. The range function helps you get a list of numbers starting from 0 going up to a certain number. For example, range 5 gives you numbers 0, 1, 2, 3, 4. So the syntax for the for loop is, here start is the starting number. This is optional to type and is considered as 0 by default. Stop depicts the ending number, which could be any number. The loop will run till the ending number 1, whereas step is the increment between numbers. This is also optional to define and is considered as 1 by default. Let us understand with an example. In this example, the start number is 1. The stop number is 6 to 1, that is 5. And the step, which is the increment between two numbers, is 2. Let us run the code to see the output. The output is 1, 3, 5. While loop. A while loop repeats a task as long as a certain condition is true, automating repeated actions without copying code. Syntax for while loop is, consider this example. Here, the loop iterates by repeatedly executing the code block, incrementing the variable I by 1 until the condition I is less than 5 is no longer true. The code begins with the value of I as 0. As 0 is less than 5, the condition is true and 0 is printed. Then the value of I is incremented using addition assignment operator. So the value of I becomes 1 now. The computer will again go back to while I less than 5 condition and checks if the condition is true, and it prints 1. Similarly, the computer will keep checking the value of I after each increment and print the numbers until while condition, that is I less than 5, is true. When the value of I is incremented and it becomes 5, the while loop stops its execution and does not print the next numbers, since the condition while I less than 5 is not true. Data structures. We use containers of boxes to hold different things. For example, a pencil box can hold pencils, erasers, and sharpeners. Similarly, in Python, data structures help us organize and store information so that we can use it easily. They can hold numbers, letters, and even list of things. We have different types of data structures, each with its own specific use. List. A list is an ordered collection of items. These are usually mutable, that is, they can be changed, and they support heterogeneous data types. The items in a list can be numbers, strings, or any other data type. Lists are written inside square brackets. For example, list 1 is equal to 1, 2, 3. List 2 is equal to apple, banana, orange. Declaration or initialization of a list. Let's understand lists with the help of an example. Fruit Mart is a company that sells fruits. If Fruit Mart wants to track the weekly sales of organic apples, they could use a list like this. Here, each element in the list represents sales figures for the day of the week starting from Monday. Listis allows the Fruit Mart team to easily update sales figures, add new daily figures, or remove figures for days not in operation. Note, an empty list is created like this. We will print this empty list with the help of print function. Let us run the code to see the output. The output shows an empty list. Operations on list. Accessing items. Items in a list are accessed by their position, known as an index. In Python, indexing starts from 0 for the first element in the list. In this example, listing the weekly sales to access the first element 300, you would see weekly sales apples 0. Similarly, for second element 450, you would see weekly sales apples 1. And for third element 520, weekly sales apples 2. Appending elements. You can add elements to the end of a list using the append method. Let us run the code and see the output. As you can see, grapes has been added to the list of fruits. Inserting elements. You can insert elements at a specific position using insert method. Let us run the code to see the output. Kiwi has been inserted at index 1, that is on second position in the list. Removing elements. You can remove elements by their value using remove method. Let us run the code to see the output. As you can see, banana has been removed from the list of fruits. Length of a list. To find the number of elements in the list, you can use the len function. Let us run the code to see the output. We can see the output 3 as there are 3 outputs mentioned in the list. Slicing lists. You can extract a portion of a list using slicing. Let us run the code to see the output. Only those fruits as mentioned, that is fruits on the index 1 and 2, banana and orange respectively, are printed. Using in operator. The in operator is used to check if a value is present in a sequence or a range of values. This is how the syntax looks like. In this example, the loop iterates by assigning each color in the colors list to the variable color one by one, starting from red and then blue and ending at green, and prints each value. In this example, the in statement checks if the value blue is present in the colors list, and if it is, it prints blue is in the list. Tuple. A tuple is an ordered collection of items similar to a list, but it cannot be altered once created, which makes it ideal for storing data that should not change. For example, product information that remains constant. It is written in parentheses and separates the elements by commas. Now, in the example use case of Fruit Mart, it can be used to store details that remains constant like product ID and name. For example, apple info is equal to 101 organic apple. Let's consider Fruit Mart needs to analyze sales data for multiple products over a week and also keep a track of product information that remains unchanged. They could use a list of sales data and tuples for product information. Operations on tuple. Accessing elements. Similar to lists, you can access tuple elements by their index. Let us run the code and see the output. It prints the first element apple that is at index 0 from the tuple. Slicing tuples. You can extract a portion of a tuple using slicing. Let's run the code and see the output. It prints the extracted elements from the indexes 1 to 3, that is numbers 2, 3, 4. Tuple length. To find a number of elements in a tuple, use the len function. Let us run the code to see the output. It prints the length of tuple as 5, thus mentioning the number of elements in the tuple. Dictionary. A dictionary in Python is an unordered collection of items, where each item is stored as a key value pair. This makes them ideal for storing and retrieving data where each element is associated with a unique key. Dictionaries are mutable, allowing for the addition, removal, or modification of key value pairs. Key value pairs in dictionaries are written inside curly braces. For Fruit Mart, dictionaries can help manage the expanding product line and customer database. Product IDs can be used as keys with corresponding product details as values. Similarly, customer IDs can serve as keys to access detailed customer profiles and order histories. Now, suppose Fruit Mart decides to use dictionaries to store product details, linking product ID keys to a tuple containing product name and price values. The for loop here goes through all the items, that is, key value pairs, in the dictionary product details. Items. Items is a method of dictionaries in Python that returns all the key value pairs of a dictionary as tuples. The for loop also takes the product IDs like 101, 102, etc. and stores it in a product ID and the product details like name and price and stores them in info. In the print command, f is an f string, also called as formatted string in Python. It allows us to include variables directly inside a string using curly braces. Product ID inserts the value of product ID, which is a key form of dictionary, into a string. For example, for the first iteration, product ID is equal to 101, so it prints product ID 101. Name info0 access the first element of the info tuple, that is info0, which is the product name. For example, for the first iteration, info organic apple 1.5, so info0 is organic apple, it prints name organic apple. Price info1 accesses the second element of the info tuple, that is info1, which is product price. For example, for the first iteration, info1 is equal to 1.5. It prints price 1.5. In addition to the product information, Fruit Mart utilizes dictionaries to manage customer data efficiently. They map customer IDs to dictionaries containing customer details, order history, and feedback. The for loop iterates over each key value pair in the customer data dictionary. Customer ID will hold the key like C001, C002 and details will hold the corresponding feedback given. In dictionaries, key value pair is separated by commas and keys are unique within the dictionary. They are also flexible and allow storing various types of data as values. The mixed dictionary here demonstrates how a dictionary can store mixed data types as values. The keys like name, age, and is student are strings while the corresponding values include a string, John, an integer 25, and a boolean true. This flexibility allows dictionaries to hold diverse data types in a single structure. Sets. A set is a collection of unique elements, which means it doesn't know how to duplicate values. Sets are an unordered collection of items, which means the items in a set do not have a defined order. Sets are mutable, which means you can add or remove items from them. Items are written inside curly braces separated by commas. You can initialize a set in a following way. Operations on sets. Add. Adds an element to the set. Let's run the code and see the output. Number 4 has been added to the set. Remove. Removes the specified element from the set. It raises a key error if an element is not present. Let us run the code to see the output. Number 2 has been removed from the set. Len returns the number of elements in a set. Let us run the code to see the output. Prints 5 since there are 5 elements in a set. Clear removes all elements from the set. Let us run the code to see the output. The set has been cleared. It's an empty set now. Copy returns a shallow copy of set. Let us run the code to see the output. Prints the copy of a set that is 1, 2, 3. Union returns a new set containing all unique elements from both the sets. Let us run the code to see the output. Prints set with numbers 1, 2, 3, 4, 5 that are unique elements from both sets. It does not print 3 times. Intersection returns a new set containing common elements between both sets. Let us run the code to see the output. It prints set with number 3 that is common element between both sets. Difference returns a new set containing elements present in the first set but not in the second set. Let us run the code to see the output. It prints set with numbers 1 and 2 which are present in the first set and not in the second set. It does not print number 3 from the first set, since number 3 is also present in the second set. Applications of sets. They can be used to track unique book title or ISBN numbers to ensure no duplicates exist. They can be used to remove duplicate values from a list of data. They can be used to keep a track of players who scored goals, making sure no player is listed twice. Sets can be used to keep a list of unique usernames or IDs to make sure no accounts with the same names are repeated. Let us understand functions in Python. Think of functions like vending machines. Instead of making snacks yourself, you just press a button and get what you need quickly and easily. Functions work in the same way, where you give an input using functions in Python and get an output without having to do everything manually. Benefits of functions. Functions organize tasks like a playlist, where related songs are grouped together for easy access, making our code clean and simple. Functions are like recipes, which you can use over and over. Once you create a function, you can reuse it multiple times, saving time and effort. Python has two types of functions. Built-in functions like print, input, int, range that we have learned and used, and user-defined functions which we can create to perform specific tasks. User-defined functions. These are the functions written by the users and follow two steps. Defining the function by a name of choice. Calling the function by a defined name. Syntax for defining the function. A function is defined using def keyword. The def keyword is followed by the name of the function. The input takes if any and the body of the function. We shall understand the key components with an example code that adds two numbers using a function and returns the sum. Function name will be the name that you give to a function. It can be any valid name. Here the function name is add. Parameters are the values the function takes. These are optional. Here parameters are A and B. Arguments and parameters. We already learned that parameters are the variables that we pass while defining a user-defined function. Here, A and B are the parameters of function add. Arguments are the actual values passed to a function when it is called. Here, 2 and 3 are the arguments passed to a function add. Always remember you can use conditional statements like if and else inside a function to make decisions based on certain conditions. Similarly, you can use looping statements like for and while to repeat actions or perform tasks multiple times. These statements help you control what the function does based on different situations and allow you to execute specific tasks repeatedly within a function. That's all for today, students. Hope you had fun learning about Python. Want to test your brain? You can attend a quiz of this chapter on Dattam's website. Once you finish attending the quiz of all the chapters, you will receive a certificate. Scan the first QR code to visit Dattam's website or click on the link provided in the description box. Scan the second QR code to learn how to navigate to assessment page and access the quiz section on the website, or click on the link provided in the description box. You can also download this PPT from the Tamsh website. Great job, little genius! You have finished lesson 3. Don't forget to like, share, and subscribe. See you in the next lesson. Happy learning!